Today we're going to focus on solving equations algebraically, and this is what most of us think of algebra as being, where we are given an equation, so we have a certain amount that is equal to a certain amount, but we have something that is missing, or we have some variable in there, and we want to solve and find out what that variable's value is. So when we are working away at this, again, what we have to keep in mind is a couple things. Number one, we want our equations to come up with a final numerical amount that our variable is equal to. So in this case, it's going to be x, or it could be n, it could be any letter that we use for that. And we also want to make sure that our left side of our equation, so if we think of breaking this up by left and right and using the equal sign as our center, that the left side is equal to the right side when we verify. So we'll get to that in a couple minutes. So for the first few questions, really quite straightforward. I'm just going to rewrite the equations so they're a little bit bigger and easier to see. So in this particular case, or number A, what we have is 2x equals 7. So obviously what we want to do is get x all by itself. So we have to think, what operation is happening with the x or is attached to the x? So in this particular case, it's multiplication. So in order to get x all by itself, what do we need to do to do that? So in this particular case, we have to do the opposite or reciprocal. So we have to actually divide by 2. And remember that whatever we're doing on the left-hand side of our equal sign, we also have to do on the right-hand side of our equal sign. So we also have to divide by 2 over here. So when I take 2x and divide it by 2, the numbers are going to, or the 2's are going to cancel out. So I'm just going to be left with x. And when I divide 7 divided by 2, I can do this a couple ways. I can think of this as being 7 over 2. If I want to simplify it, which is a good idea, I can think of it as being 3 1/2. And some of you, if you're using a calculator, when you punch that into your calculator, will come up with 3.5. Either way, that is going to work. Let's take a look at question B really quickly together. Same thing. 4x equals 3. I have to think to myself, what do I have to do in order to get x all by itself? In this particular case, because something is multiplying by x, I have to divide by that number. So I'm going to divide by 4. And whatever I do on the left-hand side, I have to also do on the right-hand side. So I have to divide by 4 over there. The 4's are going to cancel out when I divide. So 4x divided by 4 is just going to leave me with x. And 3 over 4 is going to leave me with 3/4. Or if you're using a calculator, you might come up with 0.75. Let's keep going really quickly with examples C and D. So 6x equals 3. Divide both sides by 6. Those cancel out. It's going to leave me with x. 3 over 6 is going to simplify down to 1/2, or if I'm using a calculator, that may equal 0.5. You can see, and you'll get used to this as well, that this goes fairly quickly. And lastly, 7x equals 13. Again, what do I have to do to get x all by itself? Well, I have to divide by 7, so I have to divide both sides by 7. When I divide 7x by 7, those cancel out, so I'm going to be left with x, and I'm going to be left with 13 over 7. If I was to simplify this down, it's going to give me 1 6/7 as a fraction, and if you are using a calculator, you can calculate that. I haven't used a calculator, so I'm going to leave it at that. Next, if we want to verify and make sure that our left side does equal our right side, what we have to do is actually in 2 steps. So I'm going to use 2 different color pens, one for solving and one for verifying. So I'm going to solve in purple and I'll verify in a second. So with our first question, what we have is 2x plus 3 equals 4. And again, what we want to do is we have to do a little bit of algebra. We have to do a little bit of regrouping and perhaps some dividing and use BEDMAS. And eventually what we want to get is a value or a numerical amount just for x. So in this particular case, I do want to make sure that I have all my unknowns or all my variables or all my x's on one side of my equal sign and all the numerical amounts on the other side. So I'm going to take this positive 3 and I'm going to move it to the opposite side. What this is going to become is the 2x stays where it is, the 4 stays where it is, and because this positive 3 is moving across the equal sign, the sign or the operation changes. So instead of a plus, it becomes a minus, and then the 3 stays the same. And I do need to make sure that I put that after the numbers that are already there. Then I can simplify that down slightly, so 2x equals, and then 4 minus 3, which is 1. And then if I want to get x all by itself, what I have to do is divide both sides by 2. Those are going to cancel out. And I'm going to figure out, or I think I'm going to figure out, that x has a value of 1/2. Now, when I verify, and I'm going to do this in green, what I want to do is take the value that I believe x or my variable is worth, and I want to put that or replace that back into my equation and see if the left-hand side equals the right-hand side. So I have my 2, but where I have this x, I want to replace it with 1/2. I'm going to add 3 onto it, and then that's going to equal 4. Now the equal 4 part is straightforward because that's going to stay the same. Now I have to just work away on the left-hand side to figure out what that is all equal to. So 2 times 1/2 is going to give me 1. Then I add that 3 on after the fact. And when I add my left-hand side together, I'm going to get 4, which is equal to my right-hand side. So because the left side equals the right side, I can say that 1/2 is the value of x. Take a couple minutes and figure out questions B, C, and D on your own. Make sure to verify after you have solved each equation. All right, I've worked through each of my equations in purple, and I've verified each equation to make sure that the left side is equal to the right side in green. And what you can see is that in each of the cases, when I've come up with my values for my variable or x, they have verified out in the green when I have checked them. So for question 2b, x has a value of 5/2. Now you may have simplified this down to 2 1/2 or even 2.5. That's fine, no problem, but you would have found that your left side still equals your right side if you are working that back. For question C, I have a value of 9/5, and again, you may have simplified that down to 1 4/5 or even 1.8 if you've used a calculator. Again, doesn't really matter. What you would have found is that when you verify out, that your left side does equal your right side. And finally, question D, which actually was probably the easiest question, which has a value of 2. Again, when you verify that out and do some replacing back into your equation, you can see that the left side equals your right side. Now, if you have run into a situation where you came up with, and I'll just use example D as an example, if you found that the left side equaled 12 when you did all of your calculations, but the right side equals 11, if those numbers are not the same, that's telling you that you've made an error somewhere. Maybe it's in the calculations or the checking, or the verification, or it could possibly be that you've made an error in when you have determined the value of your variable or x in the first place. So if you get a situation where the left side does not equal the right side, you do need to make sure that you go back and double check because there has been an error somewhere. All right, now obviously there are situations where we have to take some words and turn them into some type of algebraic expression. That's what we're going to practice in question number 3. So in part A, what we have is a statement telling us that 5 more than 2 times a number is 17. What is the number? Now the one thing we have to be very cautious of when we're taking worded expressions or equations and turning them into actual numerical equations is that we make sure that we put things in the right place. If we don't do this, we are going to run into some issues. So the easiest part of this is to kind of actually think of working backwards. So when we see is 17, that's telling us, or that word is telling us that whatever we have is equal to 17. So that's the easiest part to do, and that's probably where we should start. When we take a look at the first part of our sentence where it says 5 more than 2 times a number, that 5 more means that we are adding onto 2 times a number. So that plus 5 is coming after the 2 times a number. So what we have to make sure that we organize this as is 2n plus 5. This is telling us that we have 5 more than 2 times a number. Once we have got that all sorted out, then we can work algebraically to figure out what the value of that number is. So we have 2n, and we're just going to do this quickly. 17 minus 5, because remember I want to take all my numbers and put them on one side of my equal sign and then leave my variables on the other. So 2n is going to be equal to 12. And then when I want to get n all by itself, in this particular case, I've got to divide both sides by 2. So n is going to have a value of 6. We're going to skip questions B and C, and I'm going to let you do those on your own in a couple minutes. And we're going to take a look further down our page. For question 4, it tells us that the nth term of a number pattern is 7n minus 5. So for part A, it asks us what is the term value for each term. This we've had lots of practice with. We can take 7n minus 5. For that n, we can replace the number 12 because that's our term number. And we're going to subtract 5 off of it. And we're going to find out that when we do some multiplying and then a little bit of subtracting, that our value or our output number would be 79. Again, I'm going to let you do part 2 on your own, or example 2 on your own. Now for the bottom question, and again we have done this before, we want to know what is the term number for each term value. So in this particular case, this is the value right here. So that's what we have is equal to 429. And what is it that we have that's equal to 429? Well, that's of course our expression, which is 7n minus 5. We then have to do is just work through to figure out what our term number is, or the value of n is. So we can take our minus 5 and move it over. So 7n equals 429. It's a minus 5 over here, so it's got to become a plus 5 over here, because remember, the operation switches when it crosses the equal sign. So 7n equals 434. And when we divide both sides by 7 to get n all by itself, we find out that, or calculate out, that n has a value of 62. So if we were looking for a specific pattern, pattern number or term number 62 would have a value of 429. Take a couple minutes and finish all of the other questions on this page and the next page on your own. The answers or solutions will be available to you in your shared drive.